And the little subheading there is the area of a circle. Now, here is the interesting thing about area of a circle. First of all, area, when we measure the area of something, what units do we measure area in? Andrew? Yeah, we always measure area in square units, whether it be inches or feet or miles or whatever. The problem with that is, what type of a shape is a circle? Well, it's a round thing. How do you cut a round thing into square pieces? It's kind of the gist of this whole thing. And it doesn't, you can cut it into whatever squares you want, but you're going to end up with a bunch of shapes that have little round corners on it. How do you get square units out of a circle? Interesting enough. We got an idea there, Holly says?
Round square.
Well, you can do that too, but I'm not so sure what that's going to do for you. I mean, you can get maybe close to it with what the square is, but you got all these pieces here that you have to subtract. And then, so you are about to learn today, I don't know who came up with this, but this is probably the greatest thing since sliced bread. Here's what somebody did. Okay, they had a circle. And the question is, what can you do to a circle to get it to look like a square? And here is probably your answer. I'm going to do this as best I can. It's very difficult to do freehand, but I am going to try. First of all, I'm going to cut it up into pieces. How's that? Okay, now, here is what I'm going to do. Okay, here's what some fellow much smarter than I did this here. He said, okay, I need to figure out how to get a circle to look like a square. So we cut it into pieces like this. Now I've got to make sure I do this here. Right. I'm going to where's my page? Page. Bear with me. I am a trained professional. Are they coming on top of each other? That's exactly what I want to do. Because I want to stick them, I want to put them together here. Don't you worry. This will all be something else. You will go home and probably tell your parents this is the most exciting part of your day. Second point too much. Maybe there's a better way to do this. I told you it was. You get it so far?
No, not at all.
You will. This will all be worth it on them. You'll say, oh yes, that was amazing. Sorry. And then you'll want to go back and watch it all online.
Over and over and over your Saturday night.
Yes. Over and over and over. Okay. Before I lose the audience here. My pieces don't all match up, but I'm going to show you how. Anyways, he took this circle, cut it into little pie pieces, and maybe, quite possibly, he was actually eating pie and did this. And maybe the next time you have a pie, you can bet your parents that you can make that pie square. Anyways, what he did was this. He took a piece, please, brought it down here, and I think my thing should be a little, turned it on edge like that. Then he took a second piece and brought it down and spun it kind of opposite the way that thing was, like this, and then pieced that thing next to that. Then he took the other piece, took another piece, and then did the same thing, rotated it all the way around like this, slid it over here. And then he took another piece and kept alternating them until he ended up with, and mine doesn't look so much like a rectangle, but can I tell you, the smaller the pieces you cut the circle into, the more this shape will actually turn into a rectangle. Matter of fact, if you could cut them into like the smallest pieces possible, like 1,000,000, you would not be able to even tell that this wasn't a rectangle by the time you were done. I only did mine into, 8 pieces or 6 pieces or 7 pieces or whatever it is, and it kind of looks like a rectangle. How many pieces did I do?
8.
Okay, but I can tell you if you didn't, if you want a little extra credit in math, go home and do it and show me, and I'll be like, okay, but this guy. So, back to this. Once he did this, then the guy said, you know what? I know how to find the area of a rectangle. We've got that formula. What is the formula for the area of a rectangle? Area equals length times width. Okay. Well, interestingly enough, this is the width from here to here. Any idea on a circle what that height was? What was this height every time here? What is that called on a circle? What is this? It was the radius. Diameter goes all the 3, radius was just half the piece. So we know this part. The part we don't know is what is the length. And the length goes from here to here. Any idea what that part is? Sam?
Diameter?
It is not the diameter. Diameter goes through here. If you look at all these round things, this round thing could have been this thing, and then this one could have been the next one. This one could have been the next one. I'm still missing a piece. That probably would have been this one here. If I put all those together, what actually is that? Now, we check. It is exactly what that is. The length is 1/2 of the circumference. Now, I don't need to tell you this, but you probably know. We already have a formula to find the area of circumference. Anybody know what the formula for circumference is, Zach? Pi times diameter is a circumference, right? But we only wanted half of that circumference, so we have to cut this in half. And anybody know what half the diameter is? A radius. So I can cross that off and put my R there. So here, after all the smoke clears, and after all the excitement, the formula we actually get, because if I plug this in for my thing down here, the formula for the area of a circle, this is what you need to at least get down, is area equals pi times radius. Or you probably have heard it, for those smart people, area equals pi r squared. Because that's what pi times radius is. So the only thing you need to know to find the area of a circle is its radius. Okay? And it's kind of deceptive at times what that is there. It doesn't matter. All this stuff here you don't need to know. This is what you need to know. Boils down to that. So, here's a question for you. Let's say I've got a circle, and let's say its radius is, 5 inches. How many square inches do you suppose you can get in that circle? Well, that's its area. Area equals pi times 5 times 5, because area equals pi times radius. And we know pi is always that number up there. Area equals 3.14 times 5 times 5. So what is 5 times 5? So I have to take 25. Wait, was this the class we talked about? Anytime you multiply 25, it's the same as dividing by 4?
Yeah.
So if I divided this by 4, I'll get the right digits there. 5, 3 1/4, what do I get there? 0.8, something like that, I don't know. Let's just do the multiplication because I don't have time for that. 8, 2, 6, 0, 5, 8. There it is right here. 78.1/2 inches squared. That would be the area of that shape there. How?
What if you're dividing the circle into like 3?
It doesn't matter.
So you take rectangles.
I doubt it. But you would never do just 3. I mean, you get your choice. It was like, I don't know what the question or the point of that would be, but I mean, I would say, no, cut it into 5,000, you'd still probably get a rectangle. I don't know, 3, you could get, I don't know. Here's my 3 pieces. Oh wait, I can't do it, I gotta make it one fatal. Whoop, wait. Does that look like a bunch of feathers? Yeah, I'm thinking you're gonna get some sort of a strange kind of shape there. Copy. Paste. Paste. Flip. Let's try to make this one straight up and down. Right. Apparently it froze. No! Don't lock up, oh, it's gone. Now I don't remember where else it's going. Oh, I do it. No, I do it. Gabe?
So what would you want us to write for this, or what would you want us to draw in this?
You draw the circle, draw measurements, and then if it asks you for area, you write the formula for the area of a circle, and then you plug in the numbers and do it. No different than anything else we do. Alex?
Can we do an example by ourselves?
Well, I'm gonna ask you a question here, because this is where I said it's a little deceptive. Let's say, and Yorkville has plenty of pizza places.
Yes.
Let's say you can go to, what's your favorite place?
Susie.
Let's say Rosati's.
Yeah.
Susie's.
I concur. Here's where one must be careful. Let's say you can go to Rosati's and buy a 10-inch pizza for $5, or they offer the 20-inch pizza for $12. You being the astute shopper and buyer that you will, which one of those would you suppose is the better deal? Some of you are like, I don't know. Which one would be the better deal, Colton? The $10 pizza for $5? Now, why would you say that?
Because two of the $5 ones was 10 and the bigger one's 12, so you said
Thank you for that, Colton. Thank you for going with me and at least proving what I'm saying here. Colton is actually absolutely wrong. Okay? And here's what you got to be careful with this, because the only way for us really to find out which the better deal is to look at how many square inches of pizza we're getting. Okay? Because twice the diameter doesn't necessarily mean twice the pizza. Why? Because area is in square units, not just in singular units. Let's look and see. I think we already did this one, right? I did that last circle I did was 5-inch radius, right?
Yep.
So I already know what's the, how many square inches was it? 70 something.
78.5.
Okay, this is 78.5 square inches of pizza. That means you could cut 78 square inches of pizza. This one here, this pizza here, if we use our formula where area equals pi times radius, what's the radius? 10, right? Because 20 is the diameter, 5 is the radius. What is 3.14 times 10 times 10? The same thing as 3.14 times 100, which is?
314.
This one is 314 square inches, which means this pizza is way over 3 times bigger than this one. Because if it, well, I guess it's not way over. It's probably really close to 3 times bigger, because this is close to 80. 80, no, it's way over 3 times bigger.
Yeah.
It's almost probably 4 times bigger. If this was 80, this pizza is actually probably like 4 times bigger than this pizza. In order for it to cost the same amount, this pizza should have cost you $20, because it should cost 4 times as much. But it only cost you twice as much plus a little bit. And that's what you have to be careful with area, because area doesn't work like you think. It's when you just have a single measurement, 10 inches and 20 inches, a straight line is twice as big. But when you have area, it's a 2-dimensional thing, and you are actually doubling. You're actually doubling something twice. When you double something twice, it becomes 4 times bigger. You won't get that. Now, Alex wanted an example.